Hello, in this video I'm going to show you how to rapidly take measurements from your growth curves and put them into a table so you can extract lots of information very quickly using Ada's data button. So here, this is some of Alginity's Algin Pro data which I made using Spirulina, and of course many different parameters are measured using this. I've just plotted temperature here as an example. This is the same data set I used for my correlation plot video, if you're interested. And there are many things that I might want to do to analyse this data. And in parallel, if I want to do that, I use this button here. So first thing I can do is just in my table label the different profiles which I set for my growth experiments, because they might be different for each one. So I can add that as a row. The next thing I can show is what reactor it was that I happened to use. This is particularly useful for the Algem system, but can be useful maybe if you're actually plotting multiple different He24s together on the same graph. So you can add that. The next thing you can add is the gradients. If you want to work out the gradient of each of the individual curves between a specified time point, you select the gradient, click Add Row. So I'm interested in the calibrated density gradient. So I've selected this, and let's say I'm interested in when my plots were exponential. So I can probably best go between something like 0.2 and 0.5, so I can calculate it between there. So 0.2, 0.5. If I want to look at another gradient, I can do so. I just select Add Row again. And this again, I'll do my CD, and let's say this time I'll do it between 0.2 and 0.4. So this is obviously, because I've got this plotted in hours at the moment, this will give me the gradient in hours. If you prefer to have it in days, then obviously you need to change your x-axis. Another thing you can look at is how long it takes for your cells to reach the OD. So let's say you're interested in how quickly they got out of the lag phase. So I think they probably started doubling about, I don't know, 0.01, 0.05, yeah, there we go. So you can put that in. Again, if you're interested in another time, you can just add that again and put in a different value. This might be useful actually to also work out, what point do they reach their sort of maximum bit. So this one seemed to reach it at, around 77 hours or something. So you can do that. That's where that comes in handy. The next thing you can look at is your condition data. So here, for example, where I've plotted my temperature, it'd be nice to know what actually was the average of this yellow one over the whole experiment. I know it's sort of moving around, but what was the average of it? So you can work that out as well. So I just, again, select Add Row. There are different parameters, of course, in the Algin system, and each of the automated photoreactors measures slightly different things. But let's say I want to know what the average temperature was of my T cool. And I'm going to do the whole duration of the experiment here, so 0 to 168 hours. The next thing you can look at is at a specific time point, what was the condition? If you want to quickly work that out. So again, click Add Row. This might be nice for pH, for example, if you added something after, did the pH change at a certain time? Or, I don't know, if you're doing circadian rhythms and you want to know how much light there was at this time, just really quickly for your own notes. So I'm going to say 100 hours. And finally, you can work out what your fit parameters are for different models. So I'm going to have I've got a whole other video on fit parameters and models, so just look out for that one. But as an example here, the best thing that I like to fit normally is my Zweitering model, which I put a link to in the description below. And for this, you can work out what different things you're interested in. So if you want to know what the biomass yield was, for example, of each of these growth curves, it will tell you that, or the maximum growth rate, just one I tend to use. Again, I'm interested in this one. And the Zweitering model, why this is good is it's relevant for the entire growth curve. So it's generally good to put the whole duration of the experiment because it recognises the sort of sigmoidal curve you get in these experiments. So, and there. But if you're also interested in, when it became exponential and you want to see what the fit is for an exponential line, so for example in this points here, you can also fit an exponential line model. Pick which parameter you're interested in. And then you might want to go from hours 25 to 75. And I quite like to show my errors as well for both of these fits and these models. Okay, so you just fill all of that in, click Create Table, and a table will be created for you. So one thing that you might want to change, because obviously these all look the same and they're probably not, is the number of significant figures. So you just need to go into your Stats tab and up your significant figures.